Welcome to my channel. If you like my videos, then kindly subscribe, like and watch. Thank you.
Welcome back. Problem 5.12. So dear friends, I have solved all this problem, but unfortunately I did not record it and forget to record. So I am explaining that how you will solve this problem. So statement is draw the shear and bending moment diagram for the beam and loading and determine maximum and absolute value of shear and bending moment. So you can see this is the beam and loading is shown. So first step is to find the reaction supports or reaction forces. So if at point G there is a pin support, so if you remove that, so there will be horizontal force as well as vertical force. So this is Gy and this is Gx. Similarly at point C there is a roller support, so if you remove the roller support, so there will be a perpendicular force and let this force is C. So this free body diagram is already drawn over here, you can see. And for finding this unknown reaction forces, we will apply the moment equilibrium condition. So first equilibrium condition is sum of all moment about point G is equal to 0 and taking the counterclockwise moment as positive. So from this figure you can see that at point G sum of all moment is equal to 0. So first force that is producing moment is C. So C into perpendicular distance from C to G is 8 inch and 8 inch, which is 16 inch, and this is producing clockwise moment. So minus C into 16 is one moment. The other moment that is produced by this force 400. So 400 into perpendicular distance from this point A to G is 36. 12 plus 12 plus 12, 36, and this force is producing counterclockwise moment. So 400 into 36 is a counterclockwise moment. That is why this is positive. The third moment is due to this force 1600. So 1600 into perpendicular distance from E to G is 12. So 1600 into 12, and it is also counterclockwise, so it will be plus. The other moment that is produced by this 400 force, so 400 into perpendicular distance is 12 and it is producing clockwise, so minus 400 into 12. Their sum of all moment about point G is equal to 0. So when you calculate this, you will get C is equal to 1800 pound. Now we will apply the second equilibrium condition, that sum of all force along x direction must be equal to 0 on force in right direction is taken as positive. So you can see two forces, one is C and one is Gx, that is acting horizontally. C is in negative direction, that is why this is minus C, and G is in positive direction, that is plus Gx. So it means that Gx is equal to C. So Gx is equal to C means C is 1800, so Gx is also 1800. The third condition for finding this Gy is sum of all moment along y direction is equal to 0 and forces taking upward is as positive. So one force that is downward minus 400, that is available here. The second force is minus 1600, that is there. Minus 400, that is there, and plus Gy, that is there. Sum must be equal to 0. So when you calculate it, you will get Gy is equal to 2400 pound. Now we will come toward finding the shear forces at each section. So I have already written shear force. So first from A to E, you can see at A we have shear force equal to minus 400 because it is downward. So from A to E, this shear force will remain same and will be minus 400. So from A to E, shear force is minus 400. Now when you move till point E or you move away from point E, so total shear force will be minus 400 and minus 1600, which will be minus 2000. So E to F shear force will be equal to minus 400 minus 1600, which is minus 2000. Okay, now this force will remain same till this point. Clear? So if you want to find the shear force over here, so you have to cut it. Clear? Okay, so what till this point we have shear force of minus 2000 from E to F. but at F we have gy, which is equal to 2400. So minus 2000 plus 2400, which is equal to 400. So it means that from E to F the force will be, or from E to B, this 400 pound will be same. Clear? So this was all about shear force. Now we will find the bending moment. So bending moment from at A and B, the bending moment will be 0. Why? Because at A x is equal to 0, but shear force is available, and x is equal to 0, it means moment is equal to 0. And at B we have shear force is equal to 0. Why? Because from F to B this is minus 400, but from E to F this is F to B this is 400, F to B this is 400, and here at B we have minus 400, so 400 minus 400 will be 0, so there is no force, so moment will be 0. Okay, so at point A and B we have moment is equal to 0, that is written over here. Again at point D minus means slightly just before the point D, so if you cut it at this point and draw the free body diagram, so it will be like this. At point A we have 400 pound force, and this A to D is 12-inch distance, and when you cut it there will be a shear force and reaction moment. So moment will be equal to sum of all moment about point D minus is equal to 0. So 400 into 12 is one moment, that is counterclockwise, so it will be positive, and external moment is also counterclockwise, it will be also positive, and M will be equal to minus 4800 pound into inch. Now what if we move away from point D, slightly away from point D, that is D plus. Clear? So we will again draw its free body diagram, so you can see this is point D plus, this is the same 412-inch distance. Now at point D there is also C force that is acting horizontally, and there will be a shear force and bending moment, reaction bending moment. So we are interested to find out this moment, reaction moment. So 400 into 12 in counterclockwise, one moment is this one moment is this external moment which is plus, and one moment is due to this C force, and this C force is 1800 into perpendicular distance is 8, and when you solve it you will get moment is equal to 9600 pound into inch. Now what if we cut the beam at point E and at this point? Clear? And we will find the moment. So I have already done it. You can see this is 400, this is point D, this is point E. So when you cut it there will be a shear force and reaction moment, and this is the force C that is acting horizontally. So moment, we are interested to find out moment at point E. Sum of all moment at point E is equal to 0. So 400 into perpendicular distance is now 24, minus C, which is 1800 into perpendicular distance from C to E is 8 inch. So 1800 into 8, and this is clockwise, so it will be negative, plus this external moment that is in counterclockwise direction. So from here you will get moment at point E is 1400 pound. Now we will find the moment just before this point and after this point. This is F minus and this will be F plus, and we will concentrate on this section. Clear? I will draw, I have already drawn, so you can see this is F minus. So at this is point B where 400 pound is acting. This is point G where GY is this and GX is 1800, and this is point F. So when you cut it at F, there will be a shear force and there will be a reaction moment. So we are interested to find out this moment at point F minus. So M is clockwise, so minus M, 1800 is this horizontal force into perpendicular distance from G to F is 8 inch. So 1800 into 8, and this is producing clockwise movement, that is minus. The other movement is due to this force. 400 into perpendicular distance from F to B is 8 inch. So 400 into 12 inch. So 400 into 12, their sum must be equal to 0. So from here you will get moment is equal to 19,200 pound. Now the last portion is you have to cut the beam over F plus. So it means you will cut it and you will analyze this portion. So already drawn, this is point, so this is point B where 400 pounds. So from B to F plus point we have a distance of 12 inch, and when you cut it you will have a shear force and reaction moment. So again, if you solve this, you will get moment is equal to minus 1400 pound. Now you have all the value of shear force at different points. You can see this, and you have moment at various point. One is this value, all these values have been calculated and noted. I have drawn them separately over here. I will show you. This is the same beam and this is the shear force diagram. Okay, so on y-axis you have taken shear force, and on x-axis you have taken the length of the beam. So from A to E, the shear force calculated was minus 400. So here one division is taken as 200 pounds. So this is 200, 400, 600, 800, 1000. Similarly, minus 200, minus 400, minus 600, minus 800, and so on. So first we will plot from A to E, V is equal to minus 400. So at point A we have force of minus 400. So minus 400, first point is this, and from A to E it will be the same. So minus 400. So you have to draw a horizontal line, and that means that from A to E the shear force is minus 400. Now you can see at point E there is a load of minus 1600, that is downward. So total load shear force at point E is minus 400 and minus 600, which will be minus 2000. So it will move from minus 400 to minus 2000. So you have to join this by a vertical line. Clear? So this is point E. Now from E to F, this force will be minus 2000. Clear? But you can see that at point F there is a point Gy, there is a load of Gy that is acting vertical, and this Gy was 2400. So minus 2000 plus 24,000 will give you 4000. So 4000 is over here. So shear force will change from minus 2000 to 4000. Clear? This is point F. Now from F to B, the force is 4000. Clear? And it will be same like this. Now at point B there is a load of minus 400. So 400 positive minus 400 will bring it to the 0. So this will be your shear force diagram. Let's move to draw the bending moment diagram. So you can see all the values of bending moments have been noted over here. At A and B, moment is equal to 0. At D minus we have minus 4800. Similarly, all the values mentioned. So here I have taken one division is equal to 2000 pound. It means this is 2000, this is 4000, 6000, this is 10,000, and similarly in downward it will be negative. So at point A, moment is equal to 0, so you will have this point. Clear? At point D negative and C will on the same point. So at point D negative, moment is minus 4800. So 4800 will be here. Now you can see that shear force is a constant line with 0 degree slope. So the bending moment will be a line, linear line of first degree. Clear? So we will join A to C by using a linear line, but that is slope is decreasing because the shear force is negative. So we have joined from A to C. Now at D plus means that immediate after point D. Immediate after point D, this point, we are talking about this point. D and C are in line. So immediately after point D, the moment is changed. We have already calculated that is 9600. So you have to 9600 to 2004 8 6 8 99 and 96 is above somewhat. It will be this line. So from movement will change from C to this. Clear? Let me also check it. You have to draw them by using a line. Let me check. Okay, so this will be a straight line because the movement is changing from this 4800 to 9600. Okay, now at point E we have a moment of 4800 pounds. So at point E you have to locate 4800 pound into inch. So this will be the point, and again you can see the slope of this line is 0 degree. So movement will be 1 degree higher, and that will be a linear line. So you have to join this point with this. Okay, now at point F, just before F, the movement was minus 19,200. So you have to plot 19,200. So this is minus 19,200. You can check it, and you have to draw this line with, you have to join this line with this point. Okay, at point F plus you have minus 4800. F plus means that just immediately after point F or slightly after the point F, the moment is minus 1400. So it means that moment will change from 90,200 to minus 4800. Okay, and similarly at point B the moment will be 0, and also the shear force is a constant line from F to B. Clear? So the bending moment will be the first degree line, and since it is positive, so the slope will be upward. So when you join it, the moment will be here 0. So this is the bending moment, required bending moment diagram. Now you can see from this diagram that maximum value of absolute shear force is highest value, which is 2000. So minus 2000, so mod of minus 2000 is equal to 2000 pound. So this is the answer of shear force. We will move toward the bending moment, and you can see the maximum bending moment, maximum absolute value of bending moment is minus 19,200 pound into inch, and that will be maximum value of bending moment absolute is equal to 19,200 pound into inch. So this is the answer. I hope you have enjoyed video. Again, I'm telling you that I was while I was solving this problem, I forget to turn on the recording and solve all the problem. But when at the end I realized that I forget to switch on the recording, then I again explained this problem in order to show you that how to draw the shear force and bending moment diagram. I hope you have enjoyed and you have learned from this video as well. Thank you for watching.